Hello. I'm going to be teaching a pre-solo lesson over stalls. I'm going to set the scenario. Let's say that you are my student and we're on our fourth or fifth flight or so, and we haven't breached the subject of stalls yet. And say the night before you text me and you say that I don't understand this, I don't get it. We need to have a ground so that we can go over it. Well, this is going to be the ground that I would give. I'm going to outline this lesson in 4 parts. Part 1, we're going to go over the definition of what a stall is. So we're going to define it. Part 2, I'm going to draw some airfoils. Part 3, we'll go over one of the more important parts of it. We're going to talk about how to recover and awareness, stall awareness. And then 4, we'll go over the actual maneuver of a stall, okay? Okay, so not only is this a part of your guide in which that you go along flight school, right, in order to do this, this is a federal aviation regulation that you need to learn about, okay? 6187 states that you need to be briefed on this. Not only that you need to be briefed on this, it's one of the more important concepts in all of aviation, okay? Not understanding how to recover from a stall might lead to you losing your lift in your airplane and plummeting to the ground. And that's not something we need to do. So, let's go ahead and define what a stall is. I've boiled this down into 3 main bullet points of what this is. And that is, a stall is when you exceed the critical angle of attack. AOA just means angle of attack. So the first bullet point is a stall is when you exceed the critical angle of attack. Second bullet point is going to be when you exceed that critical angle of attack, what happens, okay? What happens is the smooth laminar airflow over the top camber of the wing becomes turbulent and separates. So, just put in short, separation of airflow over the top part of wing. Okay? You don't understand that yet, but in our second point of our lesson, we'll go over what that's going to be. And our third bullet point of the definition of a stall is what's going to happen, okay? What does this cause? It's going to cause a loss in lift. So put all into one nice long sentence. A stall is when you exceed the critical angle of attack in which separation of the airflow over the top part of the wing happens, causing a loss in lift. All right? The whole purpose of us flying an airplane is that we maintain our lift. Okay, as we go over the kind of the 4 forces of flight, okay, lift as opposed to weight, we don't ever want to have that weight be greater than our lift, especially like when we're in straight and level flight. So that's the definition of what a stall is. Let's go ahead and move on to our second point right here, and that's drawing some airfoils. So I want to go over what an airfoil is. If we could imagine a plane wing as it's standing like this, let's take this as our airfoil right here. It's just a simple cross section of the wing itself. Okay, if I were to have an airplane wing in front of me and if I were to cut it down to half, it's going to look something like this. Okay, it's going to be smooth on the bottom. It's going to have a slight curvature over the top. We call this curvature camber. Simply put, this has more surface area than the bottom part of the wing. I've been under enough wings to know that they look very smooth under the bottom. There's a purpose for that. All right. So whenever we're talking about how we lose lift in a stall, let's go over at least how a stall, or how lift is being created. As lift is being created, we have airflow coming over coming on the opposite side of the whip. Say this airfoil is in straight and level unaccelerated flight. Airflow is coming at our airfoil, called the relative wind. Alright? That relative wind is coming onto our airfoil and splitting in half. Splitting in half right there. It's coming over the top part, it's coming over the bottom part. Alright? Laminarly. And it meets at the same point back here. Okay, they try and meet at the same exact time. What this is going to cause, because what's happening up here on the top part of the wing is what we have called the Venturi effect. Okay, we have something called the Venturi effect, meaning that since this top part of the wing has more surface area to cover than the bottom half, right, they have to meet at the same exact point back here. So how does this top part of the wing, this top part airflow over the wing, meet back here than this one? Because this one has less, this bottom half has less surface area to cover than this top part. Well, this top part has to go faster. Well, when you have air coming over the wing, it has to move faster. We have what's called a drop in pressure. So we have a lower pressure on top of the wing. And we have a relatively higher pressure on the bottom of the wing. As that is happening, this high pressure wants to chase this low pressure. All right? As we see that happening, it's literally sucking up the wing. Right? If you could think of an airplane just in straight and low flight, the bottom part of the wing is literally being sucked up to cause flight. So that's at least how how an airplane flies. Let's talk about how we at least go into losing some lift, or at least how we at least climb an airplane. I'm going to draw another airfoil. I'm going to draw another airfoil too. Alright? So same thing's happening here. We have the relative wind coming up, splitting up here, and trying to meet at the center right here. This is an airfoil that's just climbing, alright? It's climbing out of a takeoff, alright? It's not stalled like this one is going to be, but this one's going to climb out of a takeoff. What's going to happen here is since its angle of attack has increased, let's actually just go ahead and define angle of attack real quick. The angle of attack is the angle in which the relative wind interacts with the chord line. What's the chord line? Well, the chord line, that's C-H-O-R-D, is the imaginary line from the leading edge of the wing to the trailing edge of the wing. As they interact with the relative wind right here, that's just going to be the angle in which the wing is off of our relative wind. That's going to come into play whenever we talk about exceeding the critical angle of attack later. So the chord line simply is the leading edge of the imaginary line from the leading edge of the wing to the trailing edge of the wing, and the angle of attack is the angle in which that chord line is to the relative wind. Alright, so this angle of attack on this airfoil is pointed up more than this one is in our straight level flight example. So as it's going, well, we have more surface area that this relative wind has to interact with over this top part of this wing because it's angled up. So literally this top part of the wing actually has a lower pressure than this one. Okay, and this higher pressure is also interacting, and it actually pushes our center of lift on our wing upward. This is how we're just going to climb our plane. Okay? So this is an airfoil that's in our climb. This is going to be an airfoil that's going to be stalled. Now watch this. The relative wind comes, interacts with our airfoil, splits all right? And it goes over the bottom half, and it can't exactly laminarly adhere to the top part because the angle of attack is being exceeded, right? It's exceeding the maximum angle of attack that is allowed, all right? So instead, it's not able to smoothly adhere to the top part of the wing. And what happens is that airfoil separates. So instead of smoothly adhering to the top part of the wing, it's going to separate. Now we don't have that pressure over that top part of the wing anymore, all right, causing a loss in lift. All right? So I want you to kind of imagine that we have these three airfoils, all right? We have one that's like this, we have one that's like this, and then we have one that's like this, all right? So whenever you go home today and you're in your car, I want you to roll down the window and have your hand out like this, outside the window, all right? As that relative wind is going to come and interact with your hand, it's just going to do this. It's going to keep it in flight, in a sense, right? Once you go kind of like that and you raise the angle of attack, what's going to happen? It's going to balloon up, right? You have this center of lift literally coming up on this airfoil. Your hand is going to be an airfoil, and it's going to make it fly. Now, if you were to exceed that angle of attack even more, what's going to happen, all right? That airflow is just going to come in and interact with the wing, and it's not going to adhere smoothly over the top part of the wing anymore. It's going to, in fact, not, you're going to lose your lift in a sense, all right? That's just exactly what's happening here, all right? So, as we kind of see that this is not where we want to be. We want to be here, okay? We want to be in here in some circumstances, like whenever we're coming up and departing the ground right here. This is perfectly fine. We want our airfoil to have the relative wind interacting with both the top part and the bottom part. So, whenever we get into this situation right here, what do we want to do? We want to come back to this right here. How do we do that? Well, we do that simply by just lowering the nose, all right, putting our yoke forward and increasing our power. Because what's that going to do? It's going to get that relative wind to come over the smooth, this top part right here, and now have our plane be flying again, all right? So if you get anything out of this lesson right here, the way to recover from this stalled airfoil, this stalled state in a plane, is nose down, power. And I'll also add as well that you want to also be on your feet and counteract it with any yaw motion with rudder, not aileron. Because this right here, you're not going to have any aileron effectiveness because you do not have any airflow over that ailerons anyways. It's a common student error that you might see. So, all right, we talked about airfoils. We talked a little bit about recovery. Let's talk about some awareness that you might see. How do we become more aware of stalls as we go fly? Well, there's a handy little horn that we might hear if we were to get anywhere near a stall. All right, it's about 5 to 10 knots of indication that we might see before we actually full brake stall. So when we go out and practice our stalls today, we're gonna put our airfoil in a stalled state, and about 5 to 10 knots of airspeed, we'll start hearing a noise. We're gonna start hearing. It's either gonna be like a voice saying stall, 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 or it's gonna be hearing like a horn. All right, and it's literally just a thing either on the edge of the wing that has like a low suction thing inside of it to where it'll adhere and actually trigger whenever that stall actually happens, or it's going to be a little stall tab. Depending on what airplane you fly, we can go look at it later, and I can teach you all about it whenever we go look at the plane. So that's how to become aware of it. Another thing too is just avoiding, how these things come about. How does a stall actually happen? Well, it's whenever you are either you're very slow and you might be at a high angle of attack. One of the more important things about a stall as well is that you can actually stall at any angle of attack and at any airspeed. Now you might say, how does that happen? Well, as we kind of look back to our definition of what a stall is, it's whenever you exceed the critical angle of attack. Now that critical angle of attack can be, well, it's just the angle between the chord line and the relative wind. Okay, if that relative wind is not very strong, all right, say that you have your power out and you're at a very high altitude, well, you could stall a lot easier. You could stall at this angle of attack rather than this angle of attack, all right? Depending on, right, if you have enough power if you have enough power into the relative wind, or if you have like not enough air density, or you maybe have not as high of a tail or a headwind. So, I mean, the relative wind is that, it's relative. So that's another thing as to the awareness of a stall. So kind of coming back into our definition, I kind of taught you about how exceeding the critical angle of attack causes the separation over the airfoil, separation over the airflow over the top part of the wing, and causes the loss of lift. All right? Any questions? Okay. So, I'm going to at least teach how you would do this realistically on a check ride, on like a stage check or something. There's two types of stalls that we do in the private pilot ACS and training and all that, and that is in a power on scenario and a power off scenario. Well, in the power on, what we're trying to simulate is that here's the runway right here. As we roll down the runway as we're about to take off, and we take off, well, if we have too high of an angle of attack, that might happen. So this is essentially a takeoff stall, right? The power off is essentially, you can think about it as a takeoff stall. And then we have the power off stall, which is going to be, say that you're landing right here, and you are flaring too high, and you get back into that high angle of attack with your power out. You could get into this scenario right here, or you're in this, you could be at really any angle of attack, right? But you get that separation of airflow over the top part of the wing with your power out. Well, that's the scenario that we're trying to train for and be aware of in the power off stall configuration. So I'll just go ahead and teach the power off maneuver. That's going to be right what we were just talking about, right? The stall in which we're coming into land. So I like to teach my maneuvers in 4 kind of categories and 4 points. I go over the purpose of the maneuver, the steps in which we're going to do it, the common errors, and the ACS tolerances. So with the power off stall, the purpose of why we're learning this is to learn how to recognize and recover from a power off stall scenario in the landing configuration. So whenever we do this, we're going to be doing this out in the practice area. So whenever we go out into the practice area and we're practicing power off stalls, first thing that we want to do is make sure that no one's around us. So what we're going to do is we're going to do some clearing turns. Okay, we're going to go to the left, 90 degrees, looking for people. All right, once we kind of look and see that no one's on our left side, we're going to go to our right, turn to our right, make sure that no one's around us, turning at the standard rate of turn, keeping our altitude, all that stuff, right? Once we've determined that no one's around us, we're going to set our reference point. Say that we're going out west. We're at a relative heading of 270. That's our inside heading. Once we see that we have our inside heading, we're going to look outside. We're going to go, hey, we see a house on our nose right here. That's going to be our outside reference, okay? So we have our inside reference, our heading at 270. We have our outside reference of that house, let's say. Next thing, we're going to recognize our altitude and our airspeed. We're going to verbalize that we see that our airspeed is below our maneuvering speed. We're going to recognize that our altitude is above our minimum altitude for the maneuver. And for most private pilot ACS tolerances, we're going to be above 1,500 feet AGL. So out in the practice area, realistically, we need to be doing a lot of our maneuvers at 2,000, 2,500 feet, right? So once we've established that we're at a safe altitude, safe airspeed, now what we want to do is set our configuration. We said that we were going to be doing a power off stall in the landing configuration. We want to set the landing configuration now. As we do that, setting the configuration, we're going to look down and see that our fuel selector is on our, both. It's either on left or right, depending on what airplane we're flying. We're going to make sure that our mixture is all the way enriched. Okay. We're going to pull our carb heat out if applicable. All right, and that's going to be set in the landing configuration. We still have flaps to add. So what we want to do is we want to pull our power back to 1,500 feet, or excuse me, 1,500 RPMs. As we do that, airspeed is going to come down. We're going to watch our airspeed go down. All right, once we've entered that white arc, we're going to start incrementally increasing our flaps. Okay, we're going to put our flaps down. All right, flaps 1, flaps 2, flaps 3. Watching that airspeed come all the way down. Okay, what we're trying to do is get into our VREF speed, which is essentially our speed that we're going to come down and land at. All right, so our VREF speed. We want to be around 65 in a Cessna. So as we kind of decrease and have our flaps in, we want to be watching that airspeed trying to get to 65. Okay, as we come down and we're simulating coming down, we've essentially set up the airplane in slow flight, right? As we've done that, we want to then simulate coming into land. So we're just going to decrease our angle of attack, get that airspeed to 65. As we do that and are ready to induce the stall, what we do is we take our power out, we raise our nose. All right, we just raise our nose to the horizon. We let that stall come to us, and we just hold it. We hold it. We keep some right rudder in because we've raised the angle of attack. All right, we hold it. We hear that stall horn, depending on if we've indicated that we're going to do this at full brake or if we're just going to do this at first indication. We're going to recover. How do we recover? Well, we're trying to compensate for that loft and lift being happening. So what we're going to do is we're going to push the nose down. We're going to increase our power. We're going to recover any sort of yaw movement with our feet, not with our ailerons. That's a common error that we see in this stall. All right. Please, just recover with your feet, okay? And also, whenever you cram that power back in, make sure that you put that carb heat back in as well. So that's going to be how we recover from a stall. Now, after you've done that, you essentially now are looking at more of the ground than you are the horizon. Go ahead and take your flaps to the recovery position, put them up 1, and then start kind of putting that angle of attack back up. As you kind of do that, your airspeed is going to be increasing, and you're going to just put your flaps up more, have that positive rate of climb, verbalize that you have that positive rate of climb, keep on increasing those flaps, okay? Once you've fully kind of recovered and you're still climbing, pitch for that VY speed, and then you've essentially recovered from a power off stall per the ACS, all right? So the standards that we're going to hold ourselves to while we do this maneuver is plus or minus 10 degrees of heading. So that reference heading that we stated earlier, right, the 270, we're going to stay between that plus or minus 10 in there. And the reason how we do that is really we just kind of step on the rudder, right? It's going to be more right rudder per se. As we kind of go down and recover all that, all right? We're also not going to exceed more than 20% bank angle. So, some common errors that we see as we kind of do stalls. Well, you could just have, the big one is that we kind of talked about is that we see students kind of try and recover the yaw movement on a stall with their ailerons. And as we kind of stated before, with no smooth laminar airflow of the top part of the wing, you're not going to have any effectiveness over the ailerons. So you're going to recover with stall with your feet. Use that rudder movement to do that. Some other common errors we might see is, whenever you actually recover from a stall, you might put your nose down, and then in in trying to recover again, you'll then put the nose up, and then you might induce what's called a secondary stall. So proper recovery techniques as we recover from the stall. Some other common errors you might see is flap deployment and flap putting our flaps back up. That might be a common area you might see. Just forgetting some of the steps as you might go along, and doing a power off stall. And that's really about it. As we kind of go out to the practice area, of course, we're going to do that power off stall. I might introduce to you the power on stall if we're all comfortable. But if anything we learned from this lesson is that the main thing that we want to learn, it's the definition of a stall, right? It's the definition of stall is whenever you see the critical angle attack. It's when separation over the airflow over the top part of the wing becomes separated and you lose lift. We recover from that by putting our nose down, increasing power, and that's pretty much the main part of the lesson right there. So that was our pre-solo lesson over stalls.